question number 14, and this is section B, which carries 55 marks. You are supposed to answer all the questions in this section in the spaces provided. So part A of question number 14, figure 8 shows a bucket filled with water and tied to one end of a string, which is used to whirl it in a vertical circular path with a uniform speed, that is the velocity. So we have a bucket here with water, so it is being whirled around vertically. Part A of the question says state two forces acting on the bucket at any instant. So one of the forces is its weight or gravitational force. And this is the first one, and the other one is tension, or we can call it the centripetal force acting on the string. Part Roman number 2, explain why the tension is lowest at A. You can say at A here it is vertically upward, so we have both the weight and centripetal force are acting in the same direction. So we can say part of centripetal force required is provided by weight they both act in the same direction. They both act in the same direction. Therefore tension will be less. Because now the weight is vertically above and also tension, so it reduces, they are both acting the same direction. Part Roman number 3, the speed of bucket is gradually reduced. Explain what is likely to be observed when the bucket is at point A. When the bucket is at point A and the speed is reduced, it means the weight may overcome the centripetal force, and therefore water is likely to pour out. So we can say water is likely to pour out at a certain minimum speed. At a certain minimum speed, the centripetal force is less than what is required to keep the motion. Less than what is required to keep the motion. So that is why some water may spill out of the bucket. So let's go to part B of the question. This is question number 14, part B. A stone of mass 40 grams is wheeled at the end of the string in a horizontal circular path at a speed of 12 meters per second. The string and the stone are in the same horizontal plane. If the string is 1 meter long, determine the tension of the string. So we can make a simple diagram here. So this is the stone. It is being wheeled round at the horizontal. So we have the radius there. Here we have the mass, and here we have the velocity. So we say tension is the same as the centrifugal force, which is calculated as mv squared divided by r. The mass of the stone, we are told it is 40 grams. So we divide by 1,000 to make that kg. So it is 0.04 kg. So we say 0.04. You multiply by the velocity. The velocity, we are told it is 12. Multiply by 12 because it is v squared. You divide by 1, and you can use your calculator. You'll be able to get 5.6. That is 5.76 newtons. So that's how you get the tension in the string, and you'll be able to get 3 marks if you show all the working. And that is how you do that question.